Hi. So last time we created a research workflow, and I'll show you what that looks like. We had a chat trigger. It then went and fetched a whole bunch of user feedback from this spreadsheet. So here's our user feedback, and then randomized that user feedback and then limited to 10. So we got a random sample of 10 user feedback, aggregated that into some text, and then used the LLM to fetch the list of themes, and it fetched that list of themes in text format. Now, wouldn't it be nice if we could quantify those themes with a count as to how many pieces of feedback was relevant for each theme? That's what we're going to be building today. But before getting too deep into this, there are some videos that you need to have watched in order to continue. One which is obviously the last video with the research workflow. Another which is about quadrant. So we're going to be using the quadrant vector storage database, semantic database. So there's a video on adding data to the database and then retrieving that data. So you need to have watched that. And then the third video is an open router video, but that's optional because I'm using n8n in hosted instance, which means I don't have access to my local machine. So here's a plan. I've got a research workflow. It outputs some text in terms of themes. I then want to use each theme to get a ranked list of relevant user feedback, count that feedback, and then export those stats. So this is going to be the new stuff that I want to build. But going back to the n8n workflow, we'll see that there is a problem. And the problem is that we're currently fetching everything as text. Whereas when we build out workflows in n8n, n8n likes to have everything structured, a list that it likes to have the data. So having that data as text doesn't really work well for n8n. So let's fix that. Now, if I go into basic LLM chain, you'll notice this checkbox slidey thingy here requires specific output format. If we enable that and then export back out, there's an extra subnode that appears called output parser. And if we select that, the option that we want to pick is the structured output parser. And then here, n8n is going to use this example to ensure that the data coming back from the LLM is in the correct format. So what we need to do is update this so that it's in the format that we expect. So let's do that. So I want themes. So that's the JSON property themes, and then it's going to be a list of themes like theme 1, theme 2, theme 3. Cool. So now we've got that coming back as a list. And then if we go back into this thing and run it, execute it again, we'll get a nice list of themes in that JSON output. Now, in case you don't get this exact output, there's two places to check. One, which is to check which model you're using and perhaps use a different one. So let me select that, Mistral 3B, for instance. And then two, you can update this prompt. And I've got an example prompt that I can use here. And what this is doing is it kind of leans into LLM's pattern matching capabilities. So what I'm doing is I just put in, copied, pasted example user feedback and then example list of themes that I would expect it to come back with. So this is all manually written. And I've done that for 3 user feedback along with, so it's user feedback response, and then the final one is the actual user feedback we want to use, and then a placeholder for the response that we want to get back. This is a good way of prompting without having to write lots of prompts. You're just kind of like defining the output a lot more, and it allows us to use smaller models. So let's execute that. And then we've got our list of themes. Great. So now we've got a list that we can then use in subsequent parts of our workflow. Now that we have a list of themes, I want to build out 2 more nodes, which then iterates through each one of those themes and then uses each theme to extract relevant documents from our semantic database. So I'm just going to build these out because I've gone through them in previous videos. So the first one is split out, and then I'm going to drag themes into split out. So that's the split out that we want, and then that creates a list. That's a shallower list than this. This list is a little bit too deep in terms of its output than themes. This one is just a shallow list. And the next one is quadrant, vector store, add ranked documents from the vector store. And then I'm going to use as the prompt, this is a query from the split out. I'm going to put that into there. And then the other thing to pay attention to is the limit. And I'm just going to set it to 14. You can set it to any number that you want, but just to start with, just to experiment with it, I'm going to set it to a smaller limit, and I can update that later on. Remember, the way that this get ranked documents works is that it will always retrieve 14 documents. It's just that it will return them in terms of a ranked format. So the other thing that we need is to connect it to an embedding. And then now if I run that now, it's made 3 calls, and then one for each theme, and then it's fetched 14 documents each. That's 42 documents in total. So now there's 2 problems with the way that we've currently built this. One, which is it's the way that the quadrant vector store node works. The way that the add retrieve node works is that it will retrieve documents as it's going through the split out and the loop. It adds it to a single list. So that's the first problem. It's a single list. We don't know which item is related to which theme. The second problem is that it's returned a whole bunch of documents that are maybe not relevant. So it's always returning 14 documents per theme. So let's fix that problem first. And then to fix that problem, we use a filter node. And then with that filter node, put in a condition using the score, and then we want to say what we want to keep. So if the number is greater than, and I'm just going to put in an arbitrary number here. It's something that we're going to be tweaking after we've finished the entire workflow. But for now, I just need something to test with. So I'm going to set it to, I don't know, 0.2. It's discarded 9 items. So now we've got a fewer items. We had 42 items going into the filter. 33 items have been kept. So the next problem is this single list. Now, there is a way to fix this using code to tie each theme to the output, but there's actually a better way to do it without needing to go into complex code, and that is to use a for loop. So let's add a loop. It's a loop over items, and then in for loop, it'll ask you for a batch size. Just leave that as default. That's how many items it should pick up on each iteration of that loop. So now it already creates a whole bunch of connections, but just delete all of that. And I like to be in control. So the way this works is a split out splits the themes into each individual themes, and then it propels itself forward and says, for each theme, run this, run this, run this. And then now for the loop, how it works is a little bit different in that it will loop over each one individually. So it will loop over the entire workflow, and then it'll come back on itself and then loop over with the next item. So we want to keep that loop behavior. So let's connect that up. So this is what it's doing. For each theme, it's going to run through, get 14 documents from the vector store. It's going to filter out the ones that are not necessary. It's going to keep remaining ones, and it's going to iterate over the next loop. Okay, but we're still not done with this yet. Remember, what we're dealing with here is number of documents. So from here, it's retrieved 14 documents. It's kept maybe 9 of those documents, but we still got 9 documents in there. What we want is a count of those documents. So the new node that we're going to be adding is called an edit field set. So what that does is it allows us to create a new data set and transform objects and transform the data so we have it in the structure that we're after. And in here, we need to map a new data set. So go back to the loop. This will always be the current loop that it's iterating over. So drag that over to here, and then it's created a string. So instead of doing that, let's say query. So this is the query that it's going to be using to extract themes from the vector store. And it's a type of string, and then it's using that as text. So here we can see the example. And then we want to, for the next one, we want to get a count of the number of documents that we've retrieved from Quadrant Vector Store after they've been filtered. So for that, we want a number, type of number, and then we'll just type in num. So that's the number that we want. And for that, we need to switch to expression. And this is the only part that we're going to be using a little bit of JavaScript for, a little bit of code, but don't worry, it's pretty simple. Delete that 0 and then type in $input. And what that refers to is the current input. And if I say all, what that refers to is the entire list of the current input. And then if I say dot length, this is all just JavaScript, by the way, it gets the length of the filtered list. And now if we execute this step, we'll see that it has created query X number of times, like 8 times, because this is per number of documents, remember. So there's a lot of repetition in there, but don't worry, we'll fix that in just a second. We've created a new data set where we've transformed the data and we've got it in a format that we are happy with and we want to use in subsequent steps. So now let's fix this repetition problem, because we just need one document. So let's limit this. So create a limit and then max items 1, that's fine. And then there, we've gone from 8 to just 1 with the count of the number of documents. So again, here's what this looks like so far. We've split out the themes into a list. We're looping over each one of those lists. So for each theme, we fetch 14 documents from the vector store. We filter to the closest matches. We then create a new data set counting the number of documents that we've got back, and then we limit the number of documents to 1. So then therefore we don't get that repetition. Okay, so now to the last part of this, where we want to add the stats of the theme and the counts to the Google spreadsheet. And for that, in the Google spreadsheet, I've created a new sheet called stats, and I've created 2 columns, one which is called theme and one which is called number. And if we go back to n8n, we want to access Google Sheets, so Google Sheets, and we want to append or update row in sheets. So from here, select the document, use the sheet, we've got stats there, and for the column to match on, I want to match on, and it automatically picks up the columns, match on theme, and then for the theme, just drag in that query, and for the number, I could just drag in that number. So this is the benefit of having the data sort of mapped to the way we like it, because it just makes it easier for us. Now, if I execute this step, actually, let me just check the rest of it. Yep, this is all good. So now if we execute this step, it's gone ahead and added the stats to my spreadsheet. So let's delete that, go back into our workflows. So this is our what our completed workflow looks like. And I've got a chat trigger, but let me change that to a normal trigger. So let's add a trigger manually. There we go. So now let's execute this workflow. It's running a number of times per theme. And then in here, we've got a count of the themes. And now we can run this any number of times, and then we'll get a count of the themes that it has extracted. Now, isn't this so much better than throwing user feedback into a ChatGPT black box and hoping for the best? This way, I know we've got a lot of steps, but those steps mean that we've got transparency between each and individual step of that workflow, so we know what's happening as the data is being analyzed. And it also gives us a lot of opportunity to tweak things to the way that we want it. We've also learned the difference between the split out node, and the loop node, and when we might need to use each. We've learned about the edit field set to transform data in the way that we want it, and also used filters and other sort of nodes in order to get stats about our user feedback. And we've done all of this with very, very minimal code. So hopefully you found this useful. If you have, come back next time. We're going to be doing more n8n stuff.